In this problem, we want to find the zeros of the polynomial function. So we got f of x is equal to x to the third minus 5x squared minus 40x plus 200. And we're finding the zero, so that means we set this equal to 0. So we got x to the third minus 5x squared minus 40x plus 200 is equal to 0. Now we'll put our polynomial on y1 and 0 on y2 on our calculator. So we'll press y equals, clear. We've got x caret 3. Be sure you do a right arrow key if you got an E or T84. Minus 5x squared minus 40x plus 200. Then we'll down arrow, press clear on y2 and put a 0 there if you don't already have one. I did. Okay. And then we're going to do second trace, choose intersect, number 5. This first answer, I don't know, -8, -7. We do inner on first curve, inner on second curve. Let me put a -7. And press enter. Then we get -6.324555. Let's try to change this to a fraction. So we'll do second mode to exit out, math, inner. Doesn't change, so we can't use that answer. That's okay, we got some other ones. Let's try to find one we can use. So do second trace, choose 5 for intersect, inner on first curve, inner on second curve. This looks like maybe 1, 2, 3, 4, 5 or 6. We'll put 5 in for the guess and press enter. And it tells us intersection is x equals 5. Now I could try to find that other one, but since I found one decimal that wouldn't change to a fraction, I'm going to have 2. So this one will give us a decimal that won't change to a fraction. So let's take the one answer we found, plug it into synthetic division. So we'll take the 5, put it in the box. Our largest power is x to the third, so we're going to have an x to the third, an x squared, an x, and our no x. Now we're going to write down the numbers that are in front of them. There's a x, the invisible 1 before x to the third. There's a -5 before x squared, a -40 before x, and then 200 for our no x or a constant term. Now we're going to go through a series of adding, multiplying over and over until we're done. We start with our far left column. Add, 1 plus nothing is 1. Multiply, we always multiply by number in a box, by number we put down there. So 5 times 1 is 5. Add, -5 plus 5 is 0. Multiply, you always multiply by number in a box, by number you put down there. 5 times 0 is 0. Add, -40 plus 0 is -40. Multiply, you always multiply by number in a box, but number you put down there. 5 times -40 is -200. And add, 200 minus 200 is 0. Now, a remainder of 0 means you found an answer, which is no surprise. The calculator told us it was an answer, so you have to get a 0 there. Now, we started out as x to the third. This is 1 degree lower, so this will be x squared, this will be x, and this will be no x. So we're left with x squared minus 40 equal to 0. Now, whenever you're missing your middle term, there's no x part, then square root property is your best way to go. So I'll take -40, move to the right side, and it becomes a +40. Square root property. So maybe I could spell. There it is. Square root property says if you got something squared equal to something else, you drop your squared, and you put a plus or minus square root around the other side. So again, drop your squared, put a plus or minus square root around the other side. Now 40, if I did a tree diagram, 40 is, start with our first prime, which is 2. It's divisible by 2. 2 times 20. 2's prime, so I circle it. We're still on the first prime, which is 2, and 20 is divisible by 2. 2 times 10. Circle that. 10, that's 2 times 5. And both 2 and 5 are prime, so I circle them. So this becomes x is equal to plus or minus 2 times 2 times 2 times 5. Now remember, with the square root, we're looking for a pair of somethings. Here's a pair of 2's. So they're going to come out in front as a single 2. So we got x is equal to plus or minus 2, and then we're left with 2 times 5 inside, which gives us square root of 10. Largest power of your polynomial tells you how many answers, how many zeros it's going to have. It's third power, so it means we're going to have 3. There's one of them here, and this plus or minus accounts for the other 2 answers. The reason why they were decimals that wouldn't change to a fraction is they were actually radical answers.